A very good day, my group beat the doctor. Today, we would like to present about biosensors as one of the enzyme technology advancements and applications. Therefore, without further ado, let me start off with the outline of the presentation itself first. So throughout the presentation, we are going to talk about what are exactly biosensors, what are exactly glucose biosensors, what is the application of glucose biosensors, and lastly, what is the working principle of glucose biosensor. So, first of all, let us take a look at biosensors in general first. What are exactly biosensors? Biosensor is a device that consists of three stuff, which are namely bioreceptor, transducer, and an electronic display system. So once the analyte gets detected by the bioreceptor itself, the biosensor is going to generate a signal, where in this case, the strength of the signal is directly proportional to the concentration of the analyte itself. One thing to bear in our mind is that there are many different types of biosensors, and different biosensors have their own functionality, selectivity, reproducibility, stability, sensitivity, and linearity.
Now let's focus on glucose biosensor. Now, glucose biosensor can measure the level of glucose based on the interactions with either three enzymes, and the first enzyme is hexokinase, the second enzyme is glucose oxidase, the third enzyme is glucose 1-dehydrogenase. In this case, glucose oxidase, GOX, is a standard enzyme for glucose biosensor. Why is this so? Because GOX is easily obtainable, it is cheap, it can withstand extreme pH and temperatures. Now, let's talk about the applications of glucose biosensor. The first application of the glucose biosensor is in clinical application. It is used by the diabetic patients in their disease screening and diagnosis, and it also can be used by the patients to monitor their blood glucose level. The second application is that the glucose biosensor is used to monitor the blood glucose level in farm animals. This is because the amount of metabolites in the tears of the farm animals reflects the level of metabolites in the blood, and then this helps to detect the amount of glucose metabolites in the blood of the farm animals. The third application of glucose biosensor is that it is used in bioprocess because it is able to monitor the level of glucose in agitation condition for bioprocess application, and the increase in the glucose in the environment is reflected by the glucose biosensor for a time being of 72 hours.
Hi, my name is Winjali. My metric number is S63076. This is the working principle of the glucose biosensor. This is the scheme of the Emperor glucose biosensor. The step 1 is glucose-specific enzyme. The glucose biosensor uses the glucose oxidase, which is GOX, as a bioreceptor that immobilizes on the recognition layer. The recognition layer is the partially permeable membrane that only allows the glucose substrate to reach the immobilized GOX. Step 2 is enzymatic reaction. The GOX catalyzes a reaction in which the glucose substrate is oxidized to form the gluconic acid and hydrogen peroxide as the product. Step 3 is the transducer. The hydrogen peroxide produced is oxidized at an electrode that causes the electron transfer. The electrochemical sensing of the glucose is based on the oxygen consumption. The Emperor electrochemical transducer in the glucose biosensor monitor the electric generated when the electrodes are transferred between a biological system and an electrode.
Step 4 is electrical signal measurement, in which the electrical signal is produced by using the biosensor circuitry, and the signal is proportional to the concentration of glucose inside the sample. As the figure shows below, the biosensor electronic will convert the signal into a digital readout. Step 5 is calibration. Calibration can provide accurate glucose level in which the output measurement is compared to the non-glucose concentration by using a standard reference solution. Calibration data will create a relationship between the electrical signals and the actual blood glucose level. In conclusion, glucose biosensors have become very important tools in the field of diabetes diagnostic. The advancements that found in glucose biosensors have resulted in a more accurate measurement and better data interpretation. There are a lot of applications found in glucose biosensor which extend beyond the diabetes management and contribute to various glucose-related illnesses. The glucose biosensors are making a huge impact on healthcare by allowing for efficient glucose monitoring and shortening the diagnosis duration. And these are our reference, and thank you for watching.